formula part 2. In this video I'm going to show you where the quadratic formula comes from. I'm going to derive that formula. It will take a little bit of time and it will be quite abstract. So for those of you really trying to push the boundaries of your knowledge and understanding, your depth of understanding, and achieve the highest mark you can, it's really worth engaging with this and trying your hardest to understand it, because the algebra is really rich and will help you with your algebraic skills. But this will never be asked of you. You won't be asked in an assessment to actually do this proof. So you don't have to worry about memorizing it or anything like that. But ask the questions of your teacher. Make sure that you understand it if you want to be able to take your understanding further. So let's start with ax squared plus bx plus c is equal to 0. And so the whole foundation of this proof is the idea that we're going to complete the square on a general quadratic. So this is a quadratic in standard form in front of us with an a, a b and a c that are unknown, and every quadratic can be written in this form. So if we can complete this algebraically by completing the square, then we'll have an algebraic solution for x, and we can substitute in a, b and c to get our numeric solutions. So let's start by using that completing the square technique that we learned earlier. And I'm going to be a little bit clever about colours. So I'm going to start by factorising out my a. And I'm going to use colours to show you what I do each step along the way. And I have a plus c still, but inside I have x squared plus b over a x. So that b has been divided by a as part of the factorising. Now the next step will be to do the completing the square process. So I've got my a is still on the outside, but on the inside I have x plus b over a all squared. So b over 2a, because I have to halve it. So halving b over a will give me b over 2a all squared. And then I have to subtract that leftover bit, so b over 2a squared. And so go back to that completing the square method, and you'll note that this is our process. It's just algebraic at the moment. I've divided the b over a by 2. I put that in my x plus b over 2a and square that, and then I subtract that extra b over 2a all squared. And now I'm going to follow through the usual process. So I'm going to do that expansion, which will leave me with a x plus b over 2a squared, but I'll have this additional now, b over 2a squared being b squared over 4a squared times by a. So that gives me an extra a on top there because I expanded out the brackets with this a out the front. And of course I still have my plus c just hanging around. And so now I'm going to recognise there's a simplification that can take place there, and I'll write down my current position. I've got a x plus b over 2a squared minus b squared over 4a plus c is equal to 0. Now at this point it's nice to recognise here that we've removed the original equation with 2x terms to an equation with just one x term, which is our ultimate goal. So that's good. And now I can just go through the normal procedures to solve this equation. So the first thing I'm going to do is remove my constant term at the end. So that's this term here. And I'm going to do it by adding b squared over 4a and subtracting c. So I'll end up with a x plus b over 2a all squared still. But on the other side, the right hand side, I now have b squared over 4a minus c. Now I'm going to divide both sides by a, and that will give me x plus b over 2a squared is equal to, dividing the other side by a, gives me b squared over 4 minus c, and the c is now over an a, and the b squared is now over 4a squared. And now I've got those two fractions, I'm going to combine them together. So I'll have to do this by writing this original one as x plus b over 2a squared equals. Here the first one will stay the same, but the second one will change. So the 4a squared already includes the denominator of the second fraction. The second fraction I'm going to write as 4ac over 4a squared. You notice here that I have multiplied by 4a and by 4a, and that gives me the same denominators in both fractions. And now I can combine these. So there's my left hand side, and over here I get b squared minus 4ac over 4a squared. I hope you're starting to see the beginnings of the quadratic formula here. Some stuff you'll be familiar with. Now I'm going to take a square root, and so taking the square root will give me x plus b over 2a is equal to the square root of b squared minus 4ac over 4a squared. And this can be written down as the square root of the top, b squared minus 4ac over 2a, because the square root of the bottom is 2a. And so this is still x plus b over 2a. And now just the last step to unwrap that b is unwrap the x, I subtract the b over 2a, giving me x is equal to the square root. Oh, and additionally here with this square root I should have added the plus or minus, which I've neglected to do. The square root of b squared minus 4ac over 2a minus b over 2a. And now I'm going to write this in its final form. The minus b over 2a, you'll notice that both denominators are already the same. And so I can write this down as minus b at the front plus or minus the square root of b squared minus 4ac over 2a. See, my denominator bar there is not very straight, so I do apologise. And so there we have it. This is how we derive the quadratic formula by using the completed square form on our generalised quadratic. All the best.